Black holes are super weird and fascinating. Astronomers and physicists are really into them because they're so mysterious. They suck everything in with crazy gravity, not even light can escape. Einstein thought them up way back in 1916 as part of his theory of relativity, but we couldn't really see them until the 20th century. Then, in the 60s, some astronomers found a bright blue star in the Cygnus constellation that was giving off a bunch of X-rays. It was orbiting something invisible, and it turned out to be a black hole later called Cygnus X1. That was the first real proof that black holes existed and gave a boost to studying them. Cygnus X1 is about 6,000 light-years away and is incredibly compact with crazy gravity. That's why they call it a black hole, which is a perfect name. Since then, we have found tons of black holes all over the place. Our own Milky Way probably has over 100 million of them. They're hard to spot, but astronomers have seen a few candidates, from small ones that used to be big stars to super big ones in the middle of galaxies. Black holes even change how galaxies are made and basically decide the fate of anything that gets too close. If something gets too close to a black hole, it gets stretched out like spaghetti before getting sucked in. It is called spaghettification. Even though they're creepy and act as natural labs for testing physics, black holes are still a puzzle. We're still trying to figure them out to get a better idea of how space, time, and gravity work. They're like silent guards showing us how much we don't know. Even though the closest one is really far away, about 1,500 light-years, we still wonder if they could affect us. In 2021, scientists took the first picture of a black hole, the one in the middle of the M87 galaxy. It told us a lot about what black holes are made of and how they're put together. The picture showed that they have layers. The first layer is the event horizon, that is like the point of no return. Once you cross it, you're gone. Inside that you'll find the photon sphere, where light gets stuck orbiting the black hole. And at the very center is the singularity, the point where physics breaks down completely. Black holes are unique, which makes them hard to figure out. They might all have those three layers, but they all act a bit differently, so we can't just use the normal scientific process to figure them out. Since we can't just go drop a probe inside, for obvious reasons, we have to study them from a distance. Scientists have a bunch of ideas about how they're born and how they work. NASA studied the center of M87 and found strong evidence that it held a super big black hole controlling huge parts of the galaxy. We may not get to completely understand them, but we will keep trying, and that could lead to some new information. Back in 1963, Roy Kerr came up with a new idea that changed how we thought about spinning black holes. Kerr's idea was that it had an ergosphere. It's a zone around the black hole where the gravity is crazy, but stuff can still resist falling in. But the coolest thing from Kerr's theory was the idea of wormholes. It's a tunnel through space and time that could connect faraway places or even alternate universes. Wormholes come from how relativity says that space and time are linked together. Space and time is warped by really big stuff, creating gravity. Wormholes could be shortcuts through all of this. But there are still some questions about whether wormholes could even exist. They might be too unstable, and they might have too much radiation. And even if they did exist, relativity says that we cannot travel faster than light, so they might not even be useful for getting around the galaxy super fast. Even with all of that, the idea of wormholes sticks around. The vision embodies the alluring possibility of cosmic gateways and alternate, which encourages people to ponder the mysteries of existence. The quest to find a theory that combines gravity and quantum mechanics has led to the search for a theory of everything. One of those people is Moku, pioneered superstring theory. Instead of thinking of particles as tiny dots, it says that they're actually tiny vibrating strings. These strings vibrate and give rise to all the different particles and forces we see. Superstring theory tries to make sense of black holes, wormholes, and other weird stuff that comes out of Einstein's equations. As strings move through space and time, they create gravitational singularities and distortions. But to make the math work, superstring theory needs extra dimensions that we can't see. These hidden dimensions can be hard to understand, but they might explain some weird things about the universe. The math behind superstring theory has also helped us find links between math and physics. Even though it is impressive, superstring theory hasn't been proven yet. The extra dimensions are hard to test, so it's still mostly just an idea. Still, it's a fun idea that keeps scientists thinking. As we keep digging into theoretical physics, we're getting closer to an transformative epoch of. Quantum black holes have been a tough puzzle for physicists. Even with lots of tries, we have not found an answer yet. Edward Witten even said that superstring theory is 21st century physics that stumbled into the 20th century. But recently, there have been some advances that are giving new hope. Some physicists have found some stuff that shows that string theory might actually be able to solve the puzzle, but it is only in a two-dimensional world. It is still complicated, but the search goes on. This invites us to understand the essence between tangible reality and theoretical abstraction, where the universe's arcane truths lie waiting for revelation. The study of black holes has big implications for how we understand the cosmos. It challenges what we think we know about reality. How black holes interact with other things like neutron stars and gamma-ray bursts shows just how dynamic the universe is. Back in the 60s, some astronomers spotted something odd in the Cygnus constellation. There was this bright star, giving off tons of X-rays, orbiting something invisible. Turns out it was a black hole, now called Cygnus X1. That was the first real proof that black holes were out there, and it kicked off a whole bunch of new research. Cygnus X1 is about 6,000 light-years away and is super dense. It's got so much gravity that light can't even get away from it. That's why they call it a black hole. Since then, we've found loads of black holes all over the place. Our galaxy might have over 100 million of them. They're hard to spot directly, but astronomers have found some good candidates, from small ones made from dead stars to massive ones hanging out in the middle of galaxies. Black holes mess with everything around them. They shape how galaxies form, and if anything gets too close, it's toast. They get sucked in and stretched out like spaghetti before vanishing into the singularity at the center. It's called spaghettification. It shows how strong gravity can get. Even though black holes help us test physics, they're still pretty mysterious. We're trying to figure them out to learn more about space and gravity. They're like silent guards, daring us to explore the unknown. The closest black hole we know is about 1,500 light-years away, so no need to worry about getting sucked in. Back in 2021, scientists got the first real picture of a black hole, the one in galaxy M87. It gave us a better idea of what they look like. The image showed that black holes have layers. The outer layer is the event horizon, where there is no turning back. Inside that is the photon sphere, where light gets trapped. And at the very heart is the singularity, where the rules of physics break down. No one actually knows what goes on inside. Every black hole is a little different, which makes them hard to understand. We can't just fly in and take a look because we'd be crushed. So, we have to study them from a distance. Scientists have tons of ideas about how they're made and how they run. NASA's been checking out the black hole in M87 and has got strong proof that it's controlling things way out in the galaxy. We're still pushing to learn more. Even though black holes seem impossible to figure out, humans are ambitious and can learn, and they might reveal some secrets that will change everything. Royker came up with a new idea in 1963 about spinning black holes. He said there's a zone around them called the ergosphere, where gravity and other forces are fighting. It's a weird place that doesn't follow the normal laws of physics. The coolest thing from Kerr's theory was the idea of wormholes, which are like tunnels through space-time that could connect different parts of the universe or even other universes. Wormholes come from Einstein's theory of relativity, which says that space and time are linked together and that heavy stuff bends them. Wormholes would be like shortcuts through this bendy fabric. But it's not clear if wormholes could exist or if they'd be stable. Even if they could, Einstein said we can't travel faster than light, so they might not be as cool as they sound in movies. Still, wormholes are a neat idea that makes us think about other worlds and possibilities. It's a reminder that there's a lot we don't know. Scientists are also hunting for a theory of everything that would explain all the forces and particles in the universe. One big idea is superstring theory. It says that particles aren't tiny dots but tiny vibrating strings. The strings vibrate in different ways to create different particles. It's like a cosmic symphony. Superstring theory might help explain black holes and wormholes. When strings move through space, they can cause weird gravitational effects. The thing with string theory is that it needs extra dimensions that we can't see. It's like how a piece of paper can be rolled up so you don't see the inside. These hidden dimensions might be all around us, changing how everything works. The math behind string theory has also led to new discoveries in math itself. Even though string theory is cool, scientists haven't been able to test it, so a lot of it is just ideas. But it keeps scientists interested and pushes them to think big. As we dig deeper into physics, we're getting close to some big breakthroughs. The search for quantum black holes has been really tough. Edward Witten said that string theory is like 21st century physics that stumbled into the 20th century. But now, some physicists are saying that string theory might actually help us solve the mysteries of quantum black holes, but it's still a long and difficult road. The hunt for a unified theory makes us ask big questions about reality. What's real, and what's just an idea? The universe is full of secrets waiting to be found. Studying black holes changes how we see the universe. The way black holes interact with other things like neutron stars and gamma-ray bursts shows us how everything is connected.